Hello everybody. For this video you're going to need to grab your periodic table and perhaps your calculator if you don't want to do addition or subtraction in your head. So today we're going to be talking about, in this video, nuclear symbols. Now nuclear symbols are notations used to indicate the number of protons, neutrons, and electrons in atoms and ions. And it's useful to quickly find out the charge or the mass of an individual atom or ion. Now let's review the properties to remember for our subatomic particles, the proton, the electron, and the neutron. So I'll box up things so you should memorize in this table, and you'll want to write these things down as we discuss them to reinforce your learning and help you with memorizing the concepts. First thing is the electron. Remember, that's located outside the nucleus. Its charge is -1, and its mass is approximately 0. So when we add things up, we're going to ignore the electrons in terms of mass. Number 2, the proton. Remember again, that's located in the nucleus. Its charge is +1, and its mass, look at this, technically 1.00727, but it's approximately 1. So when we're adding things up, we just round things off to the whole number. The neutron is also located in the nucleus. Its charge is 0. Okay, there's that joke, 2 neutrons go into a bar and one says to the bartender, "Hey, how much for a drink?" And the bartender says, "For you, no charge." The mass of a neutron is approximately 1. So we're going to add just the numbers of protons and neutrons to figure out what's called the mass number for elements, atoms, ions. Okay, so let me introduce you to the atomic number notation. Now, the atomic number is oftentimes given the symbol Z in the textbook and other scientific writing. We won't ever write Z, but you'll see it in the text as you're reading through. Now, the atomic number is equal to the number of protons. And you might simply want to take notes here and write Z is equal to number of P, or write down atomic number is equal to number of P. The atomic number will always be a whole number that is placed to the bottom left of the nuclear symbol. Here, He stands for helium, and it is element number 2. It contains 2 protons. It's there on my periodic table. All right, so let's look at the model of the atom. So this is our very familiar model of the atom. The atomic number can be obtained from a model of an atom that explicitly shows little balls representing the number of protons in the nucleus. So this is a model of an atom. The protons are indicated with little plus charges, and they're highlighted in orange. And you can see how this model has 2 protons, and so we say the atomic number is 2. All right? We ignore the other stuff. All right. Now, this is where you can use your periodic table to figure out, the atomic numbers of things, okay? Now, the atomic number can be obtained from the symbol of an element or the name of an element. Here's the name lithium. So you hunt around for it in your periodic table. I found it, right? It's there on my periodic table. It has a big, bold number 3, and we also know it has a symbol, capital L, small I. So we can write down the element symbol. We know that the element number is 3, and therefore the atomic number is 3. Elements differ in the number of protons they have, okay? Carbon, for example, has 6 protons. Nitrogen has 7 protons. So if an atom has different numbers of protons, it's going to be a different element. So now we can write the nuclear symbol. We can use the element symbol Li, and then we put that number 3 in the bottom left-hand corner. So let's do some practice problems here. What is the atomic number of the following elements? All right, hydrogen, boron, carbon, and uranium. So grab your periodic table and practice these on your own to get some familiarity with this. All right, what if you have a question that looks like this? What element has 8 protons? How do you handle this? Well, first of all, we know that we can assign an element from the number of protons. So grab your periodic table, all right? And you want to look around for element number 8. Once you find it, I've highlighted it here on the screen. you just read what the name of the element is. The name of the element is oxygen. All right? What if you have a weird kind of question like this, where you're asked to analyze differences between two elements? For example, it's somewhat of a riddle. What element has 2 more protons than argon? So again, you grab your periodic table, all right, and you find argon. It's on the very right-hand side of the periodic table, okay? Argon, I found it. It has 18 protons because we have that number 18 there, that whole number, all right? That means argon has 18 protons. Now, we want to find an element that has 2 more protons than that. So add 2 to that, we get 20. Now, hunt around for element 20. I found it. It's calcium, all right? So that's how you answer this riddle here, all right? Here are some additional practice problems for you, written in many different kind of fashions, okay? So spend some time to work through these on your own and see if you can figure them out. What element has 25 protons? How many protons are in an atom of titanium? What element has 5 less protons than barium? How many protons are in Ce? That's cerium. What is the element symbol for X in 13X? There is no X on the periodic table, and we often use X to just designate a mystery element that you're hopefully going to identify. Topic number 2 is mass number. The mass number is a whole number used in nuclear symbols. It is given the symbol A in the textbook if you're reading that, and we won't use A at all, but it's capital A. The mass number is the total number of protons and neutrons in the nucleus of an atom or ion. Or simply, you can just write the mass number equals the number of protons plus the number of neutrons, okay, if you're taking notes. All right. Now, it is written in the top left of a nuclear symbol. And so this number 4 here just tells us that the total number of neutrons or protons is 4. All right. Let's take a look at a figure of this element, of this atom. So this again is our familiar model of an atom showing the neutrons in yellow, protons in orange, and electrons in blue. So electrons have a mass of 0. So if we're adding up the total mass of this guy here, electrons have about 0. Okay. Now, both neutrons and protons have a mass of approximately 1, all right? So that's easy to add up. So the model shows we have 2 protons having a mass of 2. It has 2 neutrons having a mass of about 2. So 2 and 2 is 4. So the mass number here is 4. And remember again, the total mass of an atom is primarily due to the protons and neutrons in the nucleus, okay? So we have a mass number of 4. Now, where do you get the mass numbers? The periodic table does not help us for the mass numbers, okay? Now, here's an element, manganese, okay? Element number 25. Now, there is no information about a single atom in the periodic table. What that means is that we know this atom has 25 protons by definition, but we don't know how many neutrons an atom of manganese has because we don't know which one we are talking about. We'll learn more about that in the future. Please do not ever use don't use the number below the elements, the 54.938 number here, for example, in this chapter, okay? That's going to refer to something else when we talk about the mole, all right? Now, let me introduce you to a concept called isotopes. Very, very important. Isotopes are the same element having 2 different masses, okay? Some elements have 2, 3, 4, 5, 7, whatever isotopes, okay? Here's helium-3 on the right and helium-4 on the left, okay? Now, both of these are helium because they both contain 2 protons in their nucleus, and element number 2 is helium on our periodic table. But they have slightly different masses. They have different numbers of neutrons in the nucleus. The helium-4 atom on the left has a mass of 4, as we've seen, because 2 neutrons, 2 protons, 2 and 2 is 4. And the guy on the right here, helium-3, has a mass of 3 because it's got only 1 neutron, but still 2 protons. So 1 and 2 is 3, okay? So we indicate the mass number by the nuclear symbol, as I mentioned in the upper left-hand corner, or we can follow it with a hyphen after the element name. So helium-4 means mass number 4. Helium-3 means mass number 3. So if you see an element with a hyphen and a number, that number means the mass number. It's the total number of protons and neutrons in the single atom, all right? Now, let's look at some examples to get a feeling for this, all right? So how many protons and neutrons are in carbon-12? So first, you want to grab your periodic table and hunt around for carbon. Once you find that on your periodic table, you can start building up and answering this question, okay? So this is element 6, so we know it contains 6 protons, okay? And then we can take the 12, all right? Carbon-12 is in this word problem, and we can do 12 minus 6 to get 6 neutrons. So we know carbon-12 has 6 protons and 6 neutrons because the 6 and 6 equals the whole number 12 in the word problem. How about nitrogen-13? Hunt around for nitrogen on your periodic table, and you'll see that it's element number 7, which means it has 7 protons, okay? In the word problem, we have 13. You want to do 13 minus 7, that's 6. So nitrogen-13, right, in the word problem contains 7 protons and 6 neutrons. Please, again, please do not use this 14.007 on the periodic table. How about hydrogen-2, okay? So hydrogen is element number 1. I found it. This therefore has 1 proton, and you want to calculate the number of neutrons by subtracting the mass number, right? The mass number is 2, subtract the 1 proton, you get 1 neutron left over. So hydrogen-2, otherwise known as deuterium or heavy hydrogen, contains 1 proton and 1 neutron. Let's do some more examples here that might be more complicated, okay? So we want to write the nuclear symbol for an element that has 13 neutrons and 12 protons. So you want to grab your periodic table, and this is arranged by increasing atomic number, which is the number of protons. So search for number 12, that's magnesium. So already we can write the element symbol Mg. Now, it's element number 12, so remember that the atomic number, which represents the number of protons, is on the bottom of this symbol, okay? So we got the 12. Now we need to figure out what is the mass number. The mass number is equal to the total number of protons plus neutrons, so 12 plus 13 is 25. That's our full, complete nuclear symbol for magnesium-25. How about this next one? It has 42 protons and 50 neutrons. Wow, that's a lot. So you hunt around for element 42, which is the number of protons, and you find molybdenum, okay? The symbol there is capital M, small o. What element is it? It's 42, so it has 42 protons. So we want to write that down on the bottom left-hand corner. Again, you want to add up the total number of protons and neutrons to get the mass number. 42 and 50 give you 92. So this is the nuclear symbol for molybdenum-92. Next up, we have oxygen. Oops, I said the name out by mistake. So 8 protons, 8 neutrons. We search around for element number 8. Element number 8, I've just memorized that one. It's oxygen is so important, shows up everywhere. So oxygen is element number 8. So there we are. The symbol is capital O. It has 8 protons because it's element 8. We put that on the bottom left, and then we want to figure out what the mass number is. 8 plus 8 is 16, and we put that number in the upper left-hand corner. The atomic number, the mass number might match the number on the periodic table, but that's happen chance, okay? This could be oxygen 16, which I have here, or we could be talking about oxygen 18 or oxygen 17, different isotopes, okay? So please don't use the numbers on the periodic table other than that whole number, number 8 above oxygen. All right, so there are additional practice problems for you to consider. Please work on these problems yourself and try to figure them out for practice and in reinforcing these concepts in your mind, okay? So how many protons does oxygen 15 have? How many neutrons does nitrogen 15 have? What is the nuclear symbol for carbon 14? And how many protons and neutrons are there in, here we have this strange symbol, okay? Let me give you a summary. We've talked about the atomic number, which is the number of protons. That's obtained by the whole number on the periodic table. And in our nuclear symbol, it's indicated as a bottom left subscript, okay? We've talked about the mass number. The mass number is equal to the number of protons plus the number of neutrons. It is indicated as a superscript to the left of the element symbol, okay? And it is not given to us in the periodic table. It's given to us in clues in the word problem. So if we had this information like helium-3, we would know, oh, 3, that's the mass number, okay? It's not coming from the periodic table. There is no 3 on the periodic table for helium. That in a nutshell is nuclear symbols. I hope this video helped you. Please like, please subscribe. Have a great day, everybody.